Good morning, everyone. I've come here to talk to you a bit about visualizing data in Elm. And my name is Jakub Hampl. You can find me as @Gampleman on GitHub. Follow me there. I do cool things. And let's start a bit with a bit of history. This is what web apps kind of used to look like when web apps started. And I'm not here to mock the data design because we still make apps kind of like this today. It's just the visuals have kind of changed. But all of these apps kind of share one kind of thing, and that's that they sort of manipulate individual pieces of data, right? This whole screen here represents one sort of record that somebody's manipulating, showing, reading. And at best, a lot of apps show a handful of these, a collection, but usually a fairly small collection of these records. We're talking at most a couple hundred records usually. And we even have in the industry a name for these apps. We call them CRUD apps. And it's probably not a wild claim that most apps kind of follow this pattern, although maybe add other stuff to it. But if you kind of keep doing this and you put them in your, for.com or whatever company becomes successful, you eventually end up in this situation, right? Where that's sort of what you're getting there, and that sort of shows up. And that's not that big of a number, but you get more successful and you go up the logarithmic scale and suddenly it's 600,000 records and then 6 billion records. And we can all kind of probably agree that this sort of UI doesn't really scale up to that. In fact, already these 6,000 records in my browser basically melted my laptop. And so we need some sort of better way to deal with these vast amounts of data that our apps are generating. And one of those ways is what I would like to call data graphics, but so maybe you've heard statistical pictures or plots or charts or visualizations. And they have the awesome ability to show immense quantities of data in a very, very constrained space. So if we take this example for here, this is at its full resolution rendering 10 million data points that represent the 500 million people living in Europe. And so each dot that you see on the screen represents 50 people. And so imagine all that data in a table. It would not be fun to read. And here we see several dimensions of that data, right? We see where exactly they live. The color indicates some sort of political boundaries there. And we get all this data in just a single picture. And, or this is another example right here. This is from a sequencing of a chromosome of some bacteria whose name eludes me now. I don't think you probably care too much. But, and here, the interesting thing is, it takes some skill to actually read this graph, but you can see how densely this data is packed in a single image. We see, the same data plotted against probably 20 different dimensions here. And that's again a single picture. And these are, take into account, these are only static pictures. If we add sort of a third dimension of interactivity, and we can pack immense quantities of data in a way that's sort of digestible by humans in a very short period of time. So I guess my claim is this. If you have a lot of apps like this, which Elm is already really successful at making, naturally the need arises to sort of start making apps like that that sort of take that data and make it digestible. And so what I want to talk about in this talk is what the state of the ecosystem for doing that is today. I want to go through some of the libraries that some of you who are here or some other people in the community have come up with. And I also want to talk a little bit about my own contribution to this space, which is a library called Elm Visualization. And finally, I kind of want to conclude with a few thoughts that I think are the sort of future of where we should sort of expand and where we can be the pioneers of this kind of technology. And that's what I'll leave you with. So a bit of a backstory is I came to Elm in 2006 in the summer. I decided to write an app for a company that I was working at that point. And they were collecting, they were scraping prices of different cloud providers for analyzing costs of running compute instances in the cloud. And the interesting thing is Amazon has this thing called spot instances that are sort of very on-demand instances, and their prices change probably faster than the stock market. The prices fluctuate really, really quickly. And so one of the natural features I wanted to do is show a sort of a time series plot of these prices over time so that you could sort of make some sort of judgment of whether or not buying these is a good idea for your web application. And so I was kind of searching the package index for some sort of charting library, and the only one I found was this one that literally supported these three charts. That was it. Yeah, that's a library by Simon Hampton, sitting over there. No, I mean, I'm not here to mock this. I think it was really great, and it's really pioneering work and a really necessary work. And I'm kind of showing some code here how that works. You have a data structure, you just feed it to some functions, and that's basically it. So it's really, really simple to use, but it has this sort of unfortunate property is if your data doesn't fall into that sort of format, then you're kind of out of luck. So clearly there was need to go a little further, and so I was searching on, and I found this conversation, right? So is there a package for doing charts? No. And then Evan says, no. How about you guys go do some work and actually make some? That's my summary of that conversation. And I thought, okay, right, we can do that. And thankfully, actually quite a lot of you probably, I don't know if you found that same conversation or if you reached the same conclusion, but actually quite a lot of stuff showed up pretty quickly. So this is a package called Elm Arc Diagram by Justin Mims. I don't know if he's here as well, but it kind of allows you this sort of really interactive, nice way to explore a directed graph in this sort of nice hierarchical sort of way. And this is just a sort of a way of the code. The code is really specific for this particular visualization. There's not a whole lot of ways you can particularly customize this. So it's kind of one way you can approach this sort of thing where you have a very particular visualization. Another really interesting library, which is actually fairly old, but I just didn't find it in my first exploration, is Elm Tree Diagram by Brendan Kokoschka. I'm probably really brutalizing these names, but my apologies. And if you look at the code here, the really nice thing that this library brings is that it allows the user to customize the actual rendering, and the library only takes care of the layout properties of the visualization. So it sort of allows you to really tailor the actual presentation to the way your data looks. So if your data has sort of richer properties, you can render those and sort of show more visual information in a single image. The kind of other downside of it, though, is that it sort of forces you to use its own data structure that it exposes. So you're not free to bring your own data. You have to sort of somehow convert your data into the data structure that this library provides. And I found myself that this sort of trade-off is quite hard to nail in API design for visualization libraries, where you kind of want the user to be able to bring their own data and bring their own rendering, and you sort of want to fit somewhere in the middle. And so it takes quite a lot of effort to sort of nail that. And then something really cool happened. That is, who's probably sitting somewhere here as well, Sokol released this library called Mplot, and that's really awesome and has quite a lot of stuff built in. And I'm not going to talk about it too much because there's a whole talk devoted to it later on today. So I'll save that, but it's really great. So use it if you like. And actually, the interesting thing about it is really it really uses principles kind of that come from this book by Edward Tufte, The Visual Display of Quantitative Information. And so if you want to read more about the theory behind doing these sort of things and why you want to sort of concentrate a lot of data on, I would really recommend taking a look at this book. So that's more of a further reference. And this is work that's not released yet, but I'm really, really excited about this. This is a library called Slippery Slope by Jonas Koch, who's also here somewhere, over there. I've been advised that the name is work in progress, as is the whole library, but it allows you to do cartography in Elm. And this is where the history of data visualization really comes from, because people first started drawing maps of physical things on the Earth, and then only later found out that you can actually draw maps of abstract things. And so visualizing the things on the Earth is like a really important thing, and a lot of really interesting data actually is bound still to its position on the Earth. So check that out, and also talk to him if you have more input about that. Okay, now let's talk about a little bit on visualization, which is the library I'm kind of responsible for. And it sort of follows a slightly different pattern than some of these other libraries. And I'll try to explain a little bit how that works. So here's 4 different charts, and they have a few things in common. One of them is they're all rendered using this library. But the other thing is that you'll notice that there are certain patterns and algorithms that repeat whenever you're doing even fairly diverse set of visualizations as you're doing here. And so one of them is the concept of scales. And scales is a way that you take some sort of data in whatever format it comes to you. In this case, we just have a large array of like very large numbers, and we want to convert them in various ways. So one thing you often want to do is you want to convert them to points on a 2-dimensional surface, because that's kind of the screen you tend to be rendering on. And so for that, you often use what we call linear scales, which sort of transform data into usually a more bounded set, which corresponds to the actual physical pixels of the screen. But another thing you might use is a sequential scale if you want to transform that data into, for example, color. And there's other forms of scales that you can use to transform different kind of data into things like, say, positioning for bars on a bar chart, or different kinds of symbols if you want to render a scatter plot, or other sort of but each of these are fairly abstract in the sense that they transform data into another data that's more suitable for visualizing stuff. And then axes. They're not universal, but in a lot of plots we use axes to orient the viewer. And that's sort of more of a pre-built kind of view function that actually outputs SVG in this case. But it can just take that description of a scale that you constructed before, and it can render for you a nice axis, because that's actually pretty repetitive to try to write. And then we have like all data visualizations basically use some sort of markings to represent the data. And so we have different pipelines of how you can turn data into shapes. So in one case, we have this data, and we use the scale that I've talked about before to transform it into some sort of pixels. And then we use a line generator that transforms that data into a sequence of commands for drawing a line. And that's still an abstract representation of a line. That's just a sequence of points. And then we can use a curve function, which also come with this library, that can transform that data into a particular curve. So we can choose different curve functions if we want to have a smooth one, or if it's supposed to be quite spiky, or what kind of smoothing there. And there's actually quite a lot of possible different curves that you might use in different situations. And the beauty of this system is that all of these communicate with each other just via their public API. So if you don't like how one of these is implemented, you're free. You don't have to fork Elm visualization and change it. You can just write your own version of one of these parts and just reuse the whole pipeline. A similar thing works here with a pie chart. A pie generator transforms your data into a sequence of proportions of a circle, so starting angle and ending angle. And if you don't like that, you want to render an ellipsis, you can do that. You can change it. And then an arc generator will take for each of those things and will render the appropriate SVG to draw the kind of arc that you like. And you can customize those as well. So this system kind of gives you quite a lot of flexibility in both what kind of data you have and in both what the sort of visual output should be. So let's look at some code to sort of concretize this a little bit here. So here we're going to try to render a very simple line chart. And we define two scales. One is a time scale. And we know the first kind of two pair of arguments is what we call the domain, which is what the data is going to be bounded by. So the smallest part in the data and the highest part in the data. In this case, those will be dates. And then the second pair is the range, which is what the output of that will be. And in this case, it's going to go from 0 to the width of the rendering. And we do something very similar for the Y scale. And then the axis are just functions that take those scales, potentially some options. And then finally, we have this line thing here down here that will take our data and transform it into some sort of SVG curve. And to do that, we first have to use the scales to convert it. And then we can feed it into a line generator that takes a curve function. So these are things I've talked about. And that will produce the appropriate string that we can feed into SVG, which we kind of do here. I apologize, it didn't really fit on one slide. And so that's just where we feed in the line data into this D attribute. And that actually renders this nice thing. And then we add in the axis that we defined before. And those sort of line up here. And we've defined our whole plot. Now, if this seems like a fairly large amount of code compared to the previous examples, it's because it is. So the price you pay for this sort of level of flexibility is, of course, that even for simple charts, you have to write a bit more code because everything is custom drawn. But you're able to do the exact point kind of visualization that your data deserves. Now, this is kind of a demo of some future stuff that is going to ship hopefully in a new version pretty soon. This is a layout algorithm that uses simulation of physical forces and charges between particles to sort of draw a network graph in this case. And again, this is using the same kind of principles of bring your own data and render your own visualization. So that will be coming soon. And there's further stuff that this library is hoping to bring. And there's various data structures that are really useful for data visualization, quad trees for fast computing of these sort of things. R trees are very useful for finding out the nearest labels for if you have an awful lot of points and other things. So stay tuned for a lot of that will be coming pretty soon. Now let's talk a bit about the future of data visualization. What are the things that are on the horizon that are the things we could chase and be the killer features of Elm? I want to show you this demo here. This is not rendered in Elm. This is a system that renders in real time. In this case, 4.5 million points. And you can see that that's really smooth interaction over this enormous data set. And if you try to do this today with the technologies that we have, like your computer will not hit even like 2 frames per second, let alone 60 frames per second. So I was supposed to repeat, but I guess it's not. And how do they actually achieve this? Well, in this case, they're doing all that computation on the GPU, and a lot of it and particular workers. And there's also server-side support for partitioning that data into actual texture files that are loaded. But of course, this is a proof of concept. It's not a practical system. So I think a lot of what would be worth here doing is investigating how to turn this into a practical library that can enable this sort of huge amounts of data to be rendered in a sort of a practical and easy-to-use system. So it's kind of a challenge to some of you. If you can pull this off, that would be awesome. And let's talk about this plot that you see here. oh wait, you don't see a plot. And that's unfortunately the case for kind of a good amount of our users. I said in the beginning that these vast amounts of data are easily done through data pictures, but if you can't see, a data picture isn't really that great. And if you look at a lot of the tutorials for accessibility on the web, the advice they give you is, well, render that stuff somewhere in the DOM in a table. But if table was a great user interface to begin with, then why would you bother with a data graphic? So we render data graphics because tables aren't really good enough. But the advice we get is that for people who can't see, that is supposed to be good enough. So I think one way you can tackle that is, well, what if I said, well, this chart shows the crime rate in the US of violent crime, and it's averaging about, at about 400. It's been slowly decreasing by about 2% every year, and there was kind of a market spike in 2007. It's not obviously as good as what you could see, but you at least get some sort of notion of what the data graphic is trying to show you. Now, you could enhance this system by allowing the user to query the graph about particular details, because maybe you came to the graph to find out what happened in 2006. So you could maybe ask the system to give you that data. The other thing that I also want to encourage you, which is sort of easier and more approachable to any of you who are building these sort of visualizations, is just remember basic accessibility tips, like use colors that have good contrast. Don't try to do red and green together too much to create contrast, because some people just can't see that. So just make sure, if you're building a library, try to provide good accessible default colors. And I think a good important thing here is as well, if you don't have a disability, you can often forget this stuff. So it's good to have reminders in the documentation, the place where you can change the default colors, saying you can change the default colors, but remember, use something accessible. And that's sort of what I would like to leave you with. And if you have any questions, you're supposed to tweet them, so.